Okay, so 7.7 interest. There are two kinds of interest. Probably more, but two main kinds of interest problems. One of those interest problems involves what we call as simple interest. Simple interest is simple. The second kind is called compound interest. And compound interest requires a little bit more finesse to solve. And we could teach somebody your age how to solve a compound interest problem. The problem is you have to do it for every time your money compounds or you get interest. Here's what I mean. For a compound interest problem, it'll be something like this. You've got $2,000 and you get 3% interest compounded monthly. So when do you get the interest? Every month. So if I asked you how much money's in the account after a year, you'd have to do it 12 times to figure that amount up. Now we could teach you how to do that, but you know what? When you get into higher math, there's a formula that takes care of all that in one shot. You're not ready for that formula yet. You've got to understand a few other things to be able to use that formula. And so I'll just hold off on compound interest till then. But real life is normally compound interest, depending upon the scenario. If you invest money, you really want to get compound interest. And here's the difference, and we'll talk about it here in a moment as well. Compound interest, you get interest off the amount you invest plus any interest you earn. So as you're earning interest, the amount that you're getting more interest off keeps getting bigger because you have your original investment plus the interest. Now we get interest off of both. And then next compounding period, all the money you now have, all you started with, all your interest, now we'll get interest off of that. Simple interest, the first kind we're going to talk about, is simply this. If you have a 3% interest rate, you only get it off the amount that you invest, not off any interest you earn. All right, that may not be clear to you. I think as I go through a little bit more, I can make it more clear, so hang in there. The key, of course, is the formula. You've got to memorize it. Tomorrow night when you do the homework off of these, every problem needs to start with the formula. That's an I equals PRT. You need to memorize the formula. Now, I will say this. Some like to write the formula PRT equals I. They like to flip it around. By the way, what property allows us to flip the sides? Not the commutative, but the symmetric. Awesome, you guys are great. So, but it works better if it's I equals PRT. All right, I is the interest. What is interest? Well, interest can be two different things depending upon what you're doing. Interest is extra money earned if you're investing. 30 years ago, my wife worked for the post office and she bought some savings bonds. And back then, the interest rate was pretty decent. Back then, if you bought a $50 savings bond, it would cost you $25. So it said $50 on it. And it would take you roughly about 7 to 8 years until finally you earned enough interest, compound by the way, for it to be worth $50. And in about another 7 or 8 years, if you kept it, it would double to $100. And in about another 7 or 8 years, if you kept it still, it would double to $200, etc. That's extra money earned off the original $25. Interest is the extra amount you earn, all right, when investing. However, it's the extra money not earned, but paid, owed. I'll say paid. It's the extra money paid. Probably owed is the same idea if you're borrowing. When I was in the Navy, people had what was called a slush fund. What was a slush fund? They were lenders of money. It was actually against Navy regulations. They would have gotten caught. They would have gotten in trouble. They would do this. If somebody wanted to borrow 20 bucks, they say, okay, I'll lend you 20 bucks, but next payday you owe me 40. The $20 you initially borrowed and $20 interest. The extra money you got to pay for the privilege of borrowing the 20 bucks. You guys all know credit cards, right? Your parents have credit cards. Since I was in the Navy in 1976, I got my first credit card, a Sears credit card. And I've had a credit card ever since. So that was a long time, 1976 to now. That's a long time. Credit cards. They can be a tool, they could be a problem, right? Because here's the problem. If you use them and you don't pay off your bill that month, you have to pay the interest. You have to pay extra money for borrowing the money. A lot of people get in trouble borrowing the money, not paying off the total bill at the end of the month. Then they got to pay extra money constantly. $1,000 item, by the time they're done, if they never pay the bill off, might cost them a couple $1,000 because they keep paying the interest on it. Extra money for the privilege of borrowing. By the way, some Christians say you shouldn't have any credit cards at all. They're welcome to that thought. I know this. I've taken my family out to eat, I don't know how many times, on the bonus points for my credit card. And I'll tell you this, if you're wise and you know how to manage your money, and by the way, you don't have to have a lot of money to be wise. When I got out of college, I was a male teacher in a Christian school. We didn't make much money back then. My wife just had our first kid, and she was going to be a stay-at-home mom, no work. And we were going to live off of my salary. So in my whole life, since the Sears credit card, I have never paid interest on any of my credit cards. Never. Because I don't want to pay extra money. Why would I pay extra money for it? So if we couldn't afford it, we didn't buy it. If we couldn't pay the credit card off at the end of the month, we didn't buy it. And that's the way I operate still. I pay them off at the end of the month, and you know what? They give you bonus points, and you can go out to eat. All right, enough of philosophizing. Let's go on with the problem here. So interest, extra money earned if you invest, that's to your favor. Extra money paid or owed if you borrow, that's against you. It costs you extra. P is called the principal. And it's spelled the same way as the principal of a school, the P-A-L, principal. Because your principal's your pal, right? That's how you remember. P is called the principal. The principal is the amount of money you invest or the amount of money you borrow. I don't know, you guys may know this at this point. Did anybody, when you were born, did a grandparent or an uncle or an aunt put some money in an investment for you when you were born? Anybody do that? Anybody know how much? Have an idea of what it was? You don't mind saying? Okay. So that couple thousand would have been put in an investment situation. Could have been a money market. Could be, there's a lot of different things. Could be a bond. It could, a lot of different things. That couple $1,000s, we'll say 2,000 just for example purposes, that's the principal. And Colby, you're how old now? So for the last 13 years, if you haven't messed with it yet, then for 13 years, that's been earning interest. And more than likely, it's compound interest, meaning the interest gets interest as well. So the initial couple thousand plus the interest keeps earning interest. And the longer you hold it, the more it grows. The more it grows, the more it grows. But the amount invested is the principal. Let's suppose Christina wants to get a car. So she says, Mom, go buy me a car. They go down to the car dealer. She says, Mom, I want this one. It's used. It costs $8,000. I've got $5,000 of my own because I save real well. And she takes out a loan for the other $3,000. That would be the principal. The amount you borrow is the principal, or the amount you invest is the principal. Okay. So again, what's interest? Extra money you get if you're investing your principal. What's interest? Extra money you owe if you are borrowing money, and the amount borrowed is the principal. Interest rate is exactly that. It's the interest rate. So R is the interest rate, the annual percentage rate, or APR. You might hear that on commercials. And of course, it's always in what form in every formula? Decimal form. T is the time, usually in years. I know you don't have purple, so do whatever you want there. T is the time, usually in years. So you got to know the parts of the formula, otherwise how can you use it? I equals P times R times T. I is the interest, P is the principal, R is the rate, and T is the time. All right, and then also this part. A is an amount. It's really a total. So I'm going to go here and I'm going to write total. And remember, the total is the principal plus the interest, right? The P plus the I. For example, let's suppose somebody had a $10,000 bond at your birth, and now you're 12 years older. And let's say now in that account, there's actually, and it wouldn't be that great because interest rates aren't as high now as they used to be. But let's say now there is $16,000 in that account. That $16,000 total was the $10,000 principal, right, the amount vested, and the $6,000 of interest, for a total of $16,000 in the account. You follow how that works? Now again, if you borrow money, the amount you have to pay back is the whole amount you borrowed plus whatever interest you have to pay. That's the total amount you owe. All right, so we'll use that as well as we go and do some problems. It's the total value of the investment. See, there's always two types, right? Depending on whether you're borrowing or investing. It's the total value of the investment or the total due to pay off the loan. It's the total of the investment or the total amount to pay off the loan. Okay, so come on, here we go. So number 2, simple interest, 8% of the principal. 8% of the principal. And again, you only get it once. The percentage you gain, the interest you gain is only off the initial investment. So let's work a couple problems. All right, so we got first problem. You got a $5,000 loan at 9% for 3 years, and we're asked what is the interest. Okay, so we know we're going to go to our formula right off the bat. I equals P times R times T. And somebody give me one of those spots. Edward, give me a spot.
For the P, we're going to put $5,000 only.
Correct. $5,000 is the principal. Somebody else give me a spot. Chloe, give me a spot. All right, so Chloe took the rate and put it in decimal form. 0.09 is 9%. Somebody else give me a spot. Emily?
For T, we put 3 years.
Yep, and we could leave the years off, or you could put it in. And it's T, and we're ready to find the interest, right? And all of this is straight multiplication on your calculator. So grab your calculator and punch it out, brothers. I still think of punch, brothers. Punch with care. Punch in the presence of the passengers. 8 cents for 2 cent fares, 6 cent for, I don't know, I can't remember the rest of it. Zach Skinner used to do that one. Punch it out, and always ask whom? Ask demands. Remember, you're finding interest. Hey, not bad. Too bad interest rates aren't 9% anymore. The interest alone on this, somebody raise your hand and give me the answer. Hannah, what do you got?
1,350.
It is $1,350 is the extra money that you have to pay for borrowing the $5,000. Oh, by the way, that's not so off for an interest rate on borrowing. Do you know what some credit card interest rates are? 18%. If you got a good one, maybe 12%. If you're not good, 22%, 25%, 28%. See how people get in trouble with the money? Real fast. Real fast. Real fast. This is $1,350 extra money they got to pay to borrow that $5,000. So at the end of the 3 years, how much would they have to pay off the loan? $6,350. It costs them $1,350 to borrow that money. All right. All right. B, $27,000 at 5.25% for 6 years. Let's figure this one out as an investment, though it'd be hard to get 5.25% this year because interest rates are high. All right, go ahead and try it. Start with your formula. Sub in your info, punch your numbers, and see what you get. I'm going to pause the video. All right, so $8,505 is the extra money earned because, hey, $27,000, that's a good amount of money, right? Now, what if you were borrowing the money and you had to pay 5.25%? You'd have to pay an extra $8,505 to borrow that money. Edward. I'm frozen, all right, thank you. So $8,505 would be the extra you'd have to pay if you were borrowing. It would be the extra you earned if you were investing. That's why the Bible says the borrower is servant to the lender. You don't want to be the borrower. You want to be the investor, which means you have to have some self-control. Are you going to have self-control? That means when you're young, you haven't made much money yet, you got to keep from wanting to buy everything in the world. A lot of people have a problem with that. You know, back in my day when you got married, you know what your house furniture was from? Where do you think you got your apartment furniture and stuff? You didn't even have a house. Back in my day when you got married, nobody had a house right away. How do you think you got the stuff in your house? Where'd you get it from, Colby? Yeah, your parents, your aunt, your uncle, the thrift store. Did anything match? Nothing matched. Because you're young. You know what people do now? First apartment. Oh, brand new bedroom set. Need brand new living room suite. Got to have this really cool dining room table. And how do they buy it? They charge it, and boom, right away, bam, they are right in debt. And it's a shame, but it's where our country is today. It's where young people are today, and that's a shame as well. Learn to not purchase something you cannot afford. All right, number 4. Find the investment and the amount to pay back the loan or the amount of the investment. So now we got to find both. So again, let's start with our formula. It's still I equals P times R times T. But I want you to answer both questions. I'm going to pause the video. All right, got an odd answer. DeMams doesn't like it. I either put the wrong amount in for the principal, the wrong amount for the rate, or the wrong amount for the time, or I punched them into my calculator wrong. So try punching them again. Make sure you get all your decimal points and everything. All right, so on 3, I want you to tell me just the interest. On 3. Here we go. 1, 2, 3. Boy, either I punched it wrong or you guys punched it wrong. Surely you did 5,000 times 0.11 times 1.5, right? So did I punch it wrong? 5,000 times 0.11 times 1.5 equals $825. How many got that? Okay, I didn't hear that. I heard probably the 9,000 number or whatever it was. Hey, you can't use 18, right? Go back to the first thing we said, and look, time is in years, right? So 18 months is how many years? 1.5 years, right? So 1.5. Does that make sense now that you see it? So therefore, then your total amount is $5,825. You got to pay back the principal, the $5,000. It's crazy. I'll ask these questions on a test. How much does John have to pay back on this loan? That's all I'll ask. How much does he have to pay back? And you know what some people say? $825. And I'll write on their paper, oh, what a great loan. He borrowed $5,000. He only had to pay $825 back. Wouldn't everybody be looking for that loan? Yeah. You can borrow $5,000 off of me, and you only have to pay me back $825. Now you got to pay back the principal plus the interest. So don't forget that. Be careful there. It happens a lot. All right, one more example. Do this one. Now you have an investment, $5,000. You were able to get 6.25%, and it's a 15-year investment. Tell me how much money the account has after those 15 years. Again, I'll pause the video. Here's why families are in trouble in America today. Instead of investing their money and earning extra money off of the interest, they're borrowing money and paying extra money for the benefit of using the money. It's backwards. It's backwards. It's what gets people in financial trouble, and it ruins the whole economy of the country. $9,687.50. How many got that correct? Okay, good. Again, be careful that 6.25% is 0.0625, not 0.625. 0.06 is the 6%, 25 for the quarter, right? 0.0625. Now, without that, you would have gotten an answer like $46,000 in interest. The ma'ams wouldn't like that answer. $46,000. That'd be crazy. Okay. So again, you got to ask the ma'ams, does my answer make sense? Any questions on that one? Anybody? So the principal, 5,000 times 0.0625 times the 15 years. What's my interest? $4,687.50. Add the initial loan or the initial investment of $5,000. So hey, if somebody put $5,000 in an investment vehicle for you at your birth, it's very possible that when you turn 15, your account's worth about $10,000. Because 13 years ago, 12 years ago, they may have gotten 6.25% for such a long-term investment. It's possible. People use the stock market. Sometimes you can get 6.25% in one day. One day. The problem is, sometimes you can get negative 6.25% in one day. In one day. So, and again, the time is a factor as well. This was for 15 years worth. Any other questions on that one? Okay, so I just want to finish up with the concept again of compound interest. A percent of the principal and also all interest. A percent of the principal and also all interest. So hold on a second. Don't zone out and don't pack up. I'm not done. So again, I want to explain a little bit about compound interest. And I'm going to do it in a very simple way. We're going to do a problem here. So get your pens out. I want to show you. So let's do a simple example. Let's do $10,000. We'll do it compounded annually. So we'll go COMP annually. Annually means how often? Every year. At, let's go big, Let's go 12%. And then we don't want to go too long, so let's go for 3 years. So $10,000 compounded annually at 12% for 3 years. Now, don't go ahead. Stay with me because I want to teach you. So again, when you get to Algebra 1, we'll teach you a formula that you can do this in one calculation. For us, because it's 3 years, we have to do 3 calculations. Somebody in their calculator, let's figure out if this were simple interest. It's not. Somebody do 10,000 times 0.12 times 3. 10,000 times 0.12 times 3. And raise your hand and tell me the amount. Allison, what do you got? I didn't hear you. 3,600. Okay, so with the initial 10,000, the total would be $13,600. All right, that would be simple interest, right? That's a one-time calculation. We just did the problems. Principal 10,000 times the interest 0.12 times 3 years, and then I took that interest and added it to the principal. Agreed? Everybody follow? All right, now let's do it as a compound problem. So now we got to go first year, because it's compounded every year. So then at your age, this is how you have to do the problem. And we got to do I equals P times R times T. Same formula. But we have to do it every compound period. So we're going to figure out the interest the first year. So it's going to be our 10,000 times our 0.12 for our rate times 1, because we're just doing it for 1 year. Somebody punch it out for me and raise your hand and tell me what you got. Emily, what do you got? Okay, it is $1,200. That's our interest. Now we're ready to figure out the second year. We won't write the formula again for time's sake. Stay with me now. If you go ahead, you're going to get something wrong. So it's going to be I. So what goes in for the principal right now? Colby?
11,200.
Exactly. Now the principal is $11,200. The initial 10,000, and now we have an additional 1,200 of interest. Still times the rate, 0.12, and still times a time of 1 year. Now we're doing it for another year. So now punch in 11,200 times 0.12 times 1. And somebody raise your hand and give me that answer. Amber? 1,344. Anybody agree? Okay. 1,344 is now our interest the second time. Now we got to do the third year. So what's the principal the third year? Somebody raise your hand and tell me the principal third year. Emily? Aaron? Emily, brother.
12,544.
It is now $12,544 times our rate, 0.12, times now again a year, because it's now the third year. So 12,544 times 0.12 times 1. Julia, do you have that number? $1,505.28. Agreed? Okay. So now let's find the total at the end of 3 years. Tell me the total. Somebody raise your hand when you're done and give me the total after 3 years. Total after 3 years. Emily?
4,000.
No, not 4,000. Allison?
$14,049.28.
I'm sorry, 14,049.28. And that sounds like the answer. $14,049.28. So that's about a $400 difference, yes? In just 3 years. Go another 3 years, and it'll be even more than a $400 difference. It'll be the initial 400 plus probably about another 500, maybe even another 600, and it might be a whole $1,000 difference in 6 years. In 9 years, it might be a $2,000 difference. In 15 years, it might be like a $20,000 difference. It keeps growing. Now, I know you guys don't know charts well, but simple interest looks like this. It's a straight line. And this is time, and this is the amount. Compound interest looks like this. Oops, I should do it like this. Whoa, I don't want that. Leave that where it is. It would look like this. An exponential curve up. Big difference. All right, again, all I want is you to know the principle on compound interest, because again, we're going to get to a point where we can easily figure it. This homework is not for tonight. Again, this is for tomorrow night. Don't forget quiz